Good afternoon again. I'm Nripal. So I'm the founder of Adhikary. Our main objective is always like not only creating buildings but building livelihoods too. So when you work with local materials, so it's not a structure, it's not a hardware that we're giving, but we're giving software as well. So what we are is it's a private social enterprise that looks into which is socially and environmentally committed, and it celebrates the vernacular tradition of Nepal with using materials like bamboo and earth, and we want to take this material into contemporary context. We are based in Tribhuvan, and we have office in Kathmandu. We have about 15 permanent staff with architects and 20 carpenters. In Nepal, we have amazing vernacular architecture. These have changed and adapted according to the landscape, according to the people's needs, the cultural needs, according to weather condition, according to what is locally available. But now, if you look at this map, I'm going to talk more about earthen houses. If you look, there is like about 20 or more % of houses are built with bamboo in this region. And wood, bricks, there's a lot of penetration of earthen wall houses. More you go east, these earthen houses. The cement penetration in Nepal is very low. In some regions, is as low. Eastern mountain region, it's as low as 1.15%. That's how much cement has reached. The maximum is 23%, which is in the plains where there is highway. But most of them are, like, for example, mid-western mountain region, the mud penetration, mud houses are 98.6%. And our government thinks mud is not the right way to build. So they are denying access to, they're saying whatever you've done is illegal or wrong. 98.6%. And overall, in Nepal, there's only 17% cement penetration, and most of them is concentrated in Kathmandu region. So, there was a big earthquake, and a lot of people think it was only earthen houses that collapsed, and they did collapse. But there were also a lot of, for example, in this region of Chautara in Sindhupalchok, where cement penetration is only 1.1%. Many cement houses collapsed. So there were less cement house casualties. It's because there were actually fewer in numbers. Right? It's not, of course, when you look at numbers, there were so many mud houses that collapsed, but they were because they were higher in number, in some cases 98%. In Sindhupalchok, this whole valley you go, there's so many concrete houses that collapsed, they cracked. And what we're trying to say is, it's not like, cement is bad or earth is bad. It's not about what you build with, it's how you build with. That's really important. And this is what the earthquake taught us. So, this amount of cement buildings are going up every year. And one of the earthquake was a big setback. A lot of people lost faith in earthen buildings. But there's not only natural disaster, but there's also man-made disaster. For example, this old settlement in Panauti, which is a really beautiful old Newari village. They took down all these public structures made with beautiful wood and earth, so they can make bigger roads. You know, they're knocking down like beautiful temples and earthen homes so they can make 4-lane roads with like concrete buildings on the side. It's really tragic. This is a picture from last week. And earth doesn't represent poverty. You know, this in Nepal, earth means poverty because we have not invested our human resources or our academic resources in developing it. You know, like if you even in Kathmandu University, this university, the courses on earthen building is very, very low. Like it's almost non-existent. But if you look at some like these homes in like California, New Zealand, they're making really expensive homes. You know, there are certain countries which are more progressive, like New Zealand, even though it lies in earthquake zone. You know, they're really promoting it. And California, also in earthquake zone, they have a code. And also, actually, ASTM is coming up with a code. I mean, actually, Nepal is not that bad. I mean, it has a code, but it's the energy needed to promote this material is not there, unfortunately. So for the last few years, we've been building like earthen homes in Nepal. We're trying to change the perception because we think it's not the material, but it's one that we're facing two challenges. One is the perception, you know, that we have to change. The material is great, as you saw in the last slide. It's the same material, you know, they're making beautiful homes, but it's the resistance to change is what's stopping us. So we are creating these modern homes with earthen materials to really fight this taboo. In earth, we use two different materials. One is called rammed earth. It's a tradition which dates back hundreds of years, which is very common in Nepal. It's mostly common in the northwest area. Manang, Mustang was brought in by Tibetan culture. So what it is basically you have a formwork as big as size of your wall, and then you put clay, and then you tamp it, like you tamp it till you get 50% compaction. You know, so this is and it's a really great technique because it's monolithic. It makes the whole building work as a shear wall in concrete. It has one element, and then we do reinforcement in this, which I'll show in the next slide. And then the other material is a compressed earth block. These are basically the same material, but the application is different. Like here, you make the blocks in a machine, and then you get your bricks, and then you lay them. Here, you make them in situ, on site. Yeah. Here's an example of, so in the walls, we are very aware that it's an earthquake-prone area, so we reinforce it. So we put horizontal rods at the corners and near the openings, because that's the weakest point. And then we put this mesh, this polypropylene mesh, every 50 centimeters, or every 2 feet. Here's how you see it. So this works as stops like any lateral movement. So we do regular concrete foundation, you know, and every material has its own strength. We're not like bamboo or wood earth fanatic. We want to use it judicially wherever it is needed. So yeah, we have concrete bands and rebars at the openings. So here's a section, a concrete band, a rebar, concrete band, and another concrete band on top. The rest we just use mesh for tension reinforcement. And we are doing, so this is for post-earthquake, did some drawings using the same technique but on a lower, smaller scale. These are tested, I mean not the same one, but in Chile, reinforced rammed earth walls really behave well in seismic tests. This is testing adobe without any reinforcement, and this is improved rammed earth with reinforcement, and they show really good results. So we are fighting a big battle because, like steel and concrete industry, there is a big data. If an engineer wants to design something, you can always look up on the internet and find all the data, which unfortunately we do not have. We have, like especially Kathmandu Valley, it's a museum of clay, I would say, because it's because of all the erosion, all the good clay sitting on the bottom of the hill. So it has really good quality clay, really beautiful colors like red, yellow clay, black clay. But these are not tested. So we built this material testing lab for Kathmandu University, where engineering students can test it. We want to, because earth is such a heterogeneous material, it's always changes from different location. So we put this small machine where guys can make a block and then test it, see the strength. If it's not so good, they can change it and change the composition and then test it again. And then we're building homes, with just pure clay and dirt. Here's the different examples. We're making modern homes, also schools, and post-earthquake. People say Earth is too weak to build. Well, we made this thing. It's not too weak to build. It takes 2 weeks to build. So we build this house in 2 weeks. It's after the earthquake, based on some successful studies in Bihar, 2009 flood, 2011 cloudburst, and China's 2011 earthquake, and Colombia's 2013 reconstruction process. We are creating this process, the system of owner-built reconstruction. So we give the technology to the owners, so they will choose whatever they want, the material they want to choose. We've given rammed earth formwork in some areas, we've given compressed earth block, and depending on their taste and their skill set and their budget, they choose whatever material they want. And we have a really good example of livelihood creation. We're making schools, and once we make schools, what we do is we give them the machines so they can keep it themselves. And there's a great example in Panchkal where we're giving them a machine, and so people come to the school, they borrow this machine, they rent the machine, and then they build their own homes. And last month, the teacher called me and said they earned 18,000 rupees by renting that machine, which is great because with that amount they can hire another teacher. Yeah? So the school is creating livelihood. It was hard to make. We want to create an enterprise, so the school is sustaining, and so we built this school. We using the government prototype, of a 2-story and roof. We just made some changes, added some play space in between, have big windows, use local material, put insulation in place so it becomes thermally comfortable. it's warm in winter and cool in summer. All the designs are it uses passive solar technique for heating, so it has a natural ventilation. It's good in terms of acoustic. It's a very inspiring place for study, and it doesn't use any toxic paint. In a lot of schools, they want to make it colorful, and they paint it with like really toxic paint. And also in some areas we're doing rainwater harvesting where it's needed, and it's very child friendly. And the best part of this is the local material and labor. 89% of the money that you spend stays locally. So whatever the cost is, and in general, this cost is about 30% cheaper than concrete building. For example, now if you want to use concrete design to build a 2-classroom structure, it costs around $40,000 US, but this costs around like $26,000-$27,000. So it's much cheaper. And the best part is, whatever the cost is, it is staying locally. That's it for now. Here's my information if you need. If you go to this website, there's all the information.